Next presentation is brought by Greg Bell. Greg Bell is a multidisciplined engineering management professional with more than 40 years experience in the natural resources sector. Greg pivoted to the energy minerals sector from a successful career as a recognized expert in the extraction of natural gas from unconventional resources, especially coal bed methane exploration and production. His current focus is on the energy minerals sector, especially lithium and graphite.
Not this one.
In 2015, he founded the Ruby Graphite project in southwest Montana, and after years of exploration and promoting, landed the project with Reflexed Advanced Minerals as the only flake and vein graphite source in the U.S. Greg is also currently active in the lithium exploration sector, where he serves as project manager and technical advisor for several lithium exploration projects. He has a BS and master's degrees in chemical engineering from the University of Colorado and Wyoming, and he's a professional engineer registered in the states of Arizona and Utah. He is a certified groundwater professional recognized by the National Groundwater Association. So Greg's here. He's going to tell us about the Ruby Graphite mine. Let's welcome him.
Thank you. As I was listening to the last talk, this amazing segue came along to me. This property that I'm going to tell you about, it was previously produced graphite property. It was produced from about 1900 until 1950. It was discovered in 1887 by a logger or a lumberjack that was hauling a big tree down the hill, and he pulled up this piece of mineral, and he looked at it and he said, "My God, I found a deposit of lead." And so he sent this sample to the Missouri Lead and Iron Works. And so this was 1887. And there was a gentleman there in Missouri that looked at it, and he said, "Well, this isn't lead, this is graphite. This is vein graphite. This is actually quite rare." And the gentleman's name was Pearl I. Smith. And he came to Montana. This is in the Dillon area. He came to Dillon on a hunting trip and ended up staying, and he developed this into a mine. So there's a big connection, and it's all kind of the same time period of the lead development in Missouri and when this was discovered. This is the wordiest slide I have. You can read it at your leisure. It has to be shown because Reflexed Advanced Materials, which has become my sugar daddy who is funding the exploration, they're a public company, and so they have to put these words out. Ruby Graphite is still a private early stage mineral exploration company. It's private because my wife and I own it together, 50-50. And But Reflex has an option to acquire 100% of the project, but they have to put money into the ground. They have to put money into exploration and develop the project. As I mentioned, it was discovered at the turn of the century, and it was mined up until 48 or 50. And it's unique because it's the only vein graphite deposit that is known in the United States. And there's been no graphite production in the United States for the last 40 years or more. So we're trying to, we're hoping to turn that around. The deposit is located 10 miles southeast of Dillon, but to drive it takes about a half an hour, and it's more like 15 miles. It's in the area of the talc belt. All these purple crosses out there are talc deposits, and the big Regal mine is there, and the Treasure mine is off the map, and the Barrett's talc processing plant is located right here. A lot of the talc mines can't be produced economically because they have too much graphite in them, and they it makes the white talc too dark for them. This is an outline of what I'm going to talk about. I'm going to talk about what is graphite and what's the market for it, and talk about our exploration plans. This gentleman right up here in the dark shadow wearing the hat that looks rather stern with his arms crossed, that is Pearl I. Smith. That's the man that came from Missouri that started this whole thing up. And his son, Ralph Smith, was actually a metallurgist and a professor at Montana Tech. I haven't found much more information about him than that. And then when Ralph died, he passed the property on to his kids, and I obtained a mineral exploration and mining lease from the Smith family. And so we have the rights to go into their property. I love this photograph. This is maybe the mine manager and the surveyor, and this is a state-of-the-art piece of high-tech equipment back at the time that this photograph would have been taken, which must be before 1936, because that's when Pearl Smith died. I'll talk more about the uses of graphite, but in the beginning, its main use was for making crucibles and refractories for steel making purposes, because it has a high resistance to high temperature. And so you can make nozzles out of it to extrude metallic parts and big crucibles. And so it's used very much in the steel industry. And for that reason, the demand for graphite increased dramatically during the First World War and then the Second World War, especially because most of the graphite during those two periods came from the island of Sri Lanka, or Ceylon as it was known back then. And there were shipping embargoes that prevented shipment of graphite into the United States for making battleships and tanks and things. But these guys, these are artisanal miners, and they used steel and hammers and dynamite, and they dug more than 3,500 feet of tunnel and produced more than, approximately 2,400 tons of graphite. And this was, because it was vein graphite, they would hand cob it and chip it off of the host rock, and then they bag up those chips and ship them mostly to the east. Eventually, the mine tunnels were mapped in some level of detail, and that was published by the USGS. The first mine that was developed at the turn of the century was the Bird's Nest, and these are a couple of entrances I'm showing you here. And this, as I was standing there the first time looking at this entrance on the right, I looked down at my feet, and between my feet was this beautiful piece of graphite vein on the host rock. And I took that back, and I ended up having it concentrated and metallurgy tests done on it, and they were able to recover about 95% of the graphite off the sample, and the graphite had a purity of 97% graphitic carbon. This shows the southern portion of the property. That Bird's Nest mine is right here. This must be the vicinity where the logger was hauling logs down, because this north-facing slope is heavily forested. The south-facing slope is sagebrush. But then they started up the Groundhog Mine, which is a mine complex, and this is where most of the production came from. Since that time, I stumbled upon one of their old claimed discovery pits where there's vein graphite, and then I found disseminated graphite in the granite down here at this other location. So we've got graphite showings along a strike of about 3 kilometers. This is a view looking up the hill. It's a bit rugged, and so you've got waste rock piles outside of the Doobie adit and the Smith adit over in here. Because those USGS maps were available, I was able to take a close look at the property before I started investing in staking claims. And so this is a surface map showing where the different adits were located in the waste rock piles. It shows a little bit of the geology. This blue nose up here is a marble, which is interbedded between the granite layers. Over here on the right, it's a bird's eye view of all the tunnels that they had dug with different layers color-coded. And then this is a cross-section that's drawn along this AA line that shows the different levels. There was even a level very deep down, the Antelope level, where they came in right here and they tried tunneling underneath the mine. They were thinking it was going vertically down, but it turns out that it actually dips to the northwest, and so it was dipping away from where they put the tunnel in. And so I took that information and I produced this cross section, which is orthogonal to that other one, and I outlined the graphite bearing intervals in green, and then drew some boundary lines on them. This is that deep Antelope tunnel, and they did find more graphite afterwards, after the maps were made out here further. And so it pretty much confirms this is their form of exploration, okay? There's never been any drilling out here. And this shows the true width of about 50 meters and a dip of about 50 degrees, and multiple trends. This is definitely a separate trend from this one. So so we went out and picked up a lot of property. The Smiths had 101 acres, which included a mill site where there's an old ghost town, the mining campus here, and the remnants of a concentration mill. The groundhog lode claim, which is patented, and the Smith cabin site, where there's this beautiful hunting cabin in the Van Camp Valley, which is heavily forested, and a warm water spring that runs year-round comes out of here. This spring runs year-round as well. So my wife and I, well, I did the staking, but she helped pay for them. 1,865 acres, and we've got a lot of potential out there. But that's all we knew. So this was the story that we presented to investors. And COVID came along, and it took a while to get the investors. We finally got the investors last year. So as I mentioned, flake graphite, its base use has always been as refractories for steel making, and it's also used for lubricants, brake linings, gaskets, pencils, and other things. But the modern use is as the anode material in lithium-ion batteries. And it has some physical properties that include high electrical conductivity, similar to a metal, but it's chemically inert, and so it doesn't corrode. And so they've developed a method to turn graphite, typically flake graphite, which is very, very thin, very small flakes of graphite, into anode material. And we're doing a high-tech analysis right now in Chicago on this material, and because it's vein graphite, it's thicker, and it's easier to turn it into anode material. Now you're saying, so what? Well, lithium-ion batteries should actually be called graphite batteries because they have more graphite by mass than any other material in the battery. More graphite than anything else. A typical Tesla would have 150 pounds of graphite in that car. So multiply that with the cars that are being built, and you'll see what the market is. Graphite is a critical mineral as defined by the United States. The U.S. imports all of its graphite, mostly from overseas. There's been no production for more than 40 years. So this gives a snapshot as to what the market looks like. This is battery anodes for vehicles in the purple bars, stationary applications, which could be a cell phone, a power tool, or a power wall for storing solar power at a house or something. And so we're right here, and look at where they project it's going to go. And it's going to go there because the U.S. government, they recently mandated, or I don't know if they mandated it, but they set a goal of having half of the vehicles produced and sold in the United States to be electric by 2035. So here's 2035 right here. And so that's a lot of vehicles. And Europe is doing the same thing. Actually, Europe wants to do it by 2030, half the vehicles. And China's already on the path. And so the demand for lithium-ion batteries is going to grow dramatically. And the demand for graphite, so this is the market, the graphite demand is the green bars here, is going to grow dramatically. This is the projected total supply, which can't be a correct line, I know, and we can have a separate discussion about that. But if that line is true, then the deficit and the demand is going to be more than 8 million tons a year. It's just mind-boggling. Obviously, it's not sustainable, and so I personally want all the different mines that are in development and discussion right now to come online. I am not worried about competition because there's plenty of room for everybody. In fact, if there's a shortfall of graphite, and it will stifle battery production, and people will look for a different product, okay? There will always be a solution that will be found for what we need. So right now, 1.5 million tons annually produced in the world, and 2/3 of it comes out of China. No big surprise there. China, China, China. But Madagascar and Mozambique are coming online. Brazil has always had some production. The rest of the world is very small. By 2027, that's supposed to double to 3 million tons. China's portion is going to be smaller, and Eastern Africa, shown down here in the map, is going to grow significantly, and the rest of the world is going to grow as well, and this is going to include ruby graphite, okay? It's our goal to be producing by 2027 or before. And then over time, it should continue to shift. I'm going to keep emphasizing, no production from the United States for 40 years. So I started doing research on the project in 2015, and then I acquired private mineral rights from the Smith family in 2016, and staked 96 lode claims in 2016 and 2017. Developed a business plan, spent several years searching for an investor. My wife said, "Mr. Bell, this is the last year we're going to pay those maintenance fees and all those U.S. BLM claims. You got to find," and so thank you, Lord. I found an investor in 2022, Reflexed Advanced Materials, and it turns out that I know the lead guy there, that I'd been working with them since like 2016, and so finally we were matched back together, and so they're a public company on the Toronto Stock Exchange, on the I think it's the NASDAQ, and on the Frankfurt Exchange, and he's been great at raising money. He's located in Toronto, and he knows the investors. So this is a well-financed project at this point. And my excitement just continues to grow, if you can't sense it. I'm going to walk through the geology quickly. There is a 43101 technical report that was put out just at the beginning of this year that has all this information if you'd like to read about it further. It is a sedimentary protolith, an ancient Archean sea with a layer of mudstones, siltstones, carbonates. The carbonates are now marble because it's all highly metamorphosed. Do I say it right? The granodiorite level of metamorphosis. I don't think I ever say the word right. I'm not a geologist, so I don't have those words memorized. But it's highly metamorphosed, and so the muds and the silts and the sands, they were all turned into different forms of granite, schists and gneiss, and it's layered out here, and the geologists think that there might actually be an antiform in here where the beds are folded, but they all dip to the northwest at about 50 degrees. And so again, here's where the Bird's Nest mine is and the Groundhog complex over here. This is just a simplified cross-section. the graphite is found along the interfaces between these different bedding layers. It doesn't show up really so much in this slide because this brown or orange color is not marble, but it's right off the nose here. I don't think this is drawn properly myself, because it's this cross-section line is very close to the nose of this marble here, and this marble to granite contact is what is telling us where the graphite is. It's the cause of the graphite. I'm not going to get into the details of it. I've got my theories, and we recently brought on Child's Geosciences Inc. As our current geologist, and so I'm sure they're going to come up with all sorts of great things in the future. But once we had some funding, I had already tested out this tool. It's called the Gem 2 Ski. Gem 2. And it's manufactured and sold and even rented by a company called Geofex out of North Carolina. And I tested it on the property in the vicinity of Bird's Nest, and I discovered that it worked, that we could see conductivity, presumably from the graphite, within 10 meters of surface. This is a multispectral tool, meaning that it's an electromagnetic tool. It sends out a signal, it receives a signal back, and it can do it at multiple frequencies simultaneously. And that can be important for looking at different depths and different sensitivities. And so our geologists, they went out with this tool and they walked 100 line kilometers at 200 meter spacing. And wherever it's red is where the high conductivity is. And so you can connect the dots and start seeing these trends in here. Now, some of the butterflies it's been explained to me that these are probably associated with a fault that has got some high conductivity because of the presence of water or maybe other mineralization within that fault. And the same thing is likely true over here. So we used this. What we really wanted to do was a TDEM survey using a helicopter, but didn't have the money to do it. And there was like a shortage of helicopters last year. And so we went with the next best thing, which was an electromagnetic tool that could do some mapping for us. And if you take that information and you connect the dots, then you can start drawing out different graphite trends. Now, the dark gray on here is the marble, and so you can see that the conductivity trends are along the interface between the marble and the granite, more or less. And it's more or less because this is not a definitive interpretation of where the marble is either. We're still in the process of mapping that out and figuring out where it is. But we've identified these conductivity trends. And based on these conductivity trends, we designed an IP survey. Now, the IP survey started late last year, and the snows came on fast and furious in like late November. Thanksgiving was pretty snowy. And so we had planned a third line out here, north-south line, and we had planned to extend this east-west line further to the east. But we had to terminate the survey early. And it's fine because we accomplished what we needed to. The red rectangle that I've drawn along this IP line is where the highest conductivity was. So here's another one over here. So it's verifying what we saw with the Gem 2 ski. And you can see that it comes down through here. To our amazement, it's right in the backyard of the cabin. There's a trend in there. And the strongest trend was, no big surprise, connecting the groundhog complex with the bird's nest. Okay, so this is where the strongest conductivity zone was seen. And we had crossover because we have the lines intersecting here, and we have had the conductivity on both of these lines, and so it's strong. So this is our target. We have put in permits for drilling this summer, and we're hoping to be drilling in June and July. and core, you know, I think it's about 12,000 meters is what we're planning on coring this summer. And so I'm going to go back a second. So look at this line, IP line 4, going from east to west, and you can see that the groundhog complex is fairly close to the western end of the line. Well, that's right here, and so the miners were almost into the mother lode, but not quite. So the highest conductivity we're seeing is in here. Of course, it's geophysics, so you have to use a lot of interpretation and squint your eyes and integrate this information with other information. And but from what we can tell right now, the mining people, they were right on the edge of the thing, and most of the mining was maybe a little bit above this nose, and that antelope tunnel, which they put down low, was right below the nose, and so they weren't right into the nose at all. And so we're going to drill the heck out of that thing this year, and with a success, you'll invite me back, and I'll tell you the results next year. Thank you. How are we doing? Perfect timing.
All right. Thanks, Greg. Do we have questions?
I explained everything. So anyway, we're in the market for services. So I'm interviewing environmental firms, and we're getting ready to go to the field.
You mentioned a patented claim or two. What's the rest of the land position there? Do you have a federal partner is what I'm asking.
Yeah, I like the southern third or so of the property is BLM surface, and that's where we're going to be drilling, is on the BLM surface. And so I'm working with Steve on getting a notice moved through and get some bonding paid. Besides the Smith private property, the rest of it is Stock Raising Homestead Act land. And so it's federal minerals with private surface. And so we had to go through the NOIDL process and state claims, and we have to permit activity on that land through a plan of operations that's done through the BLM. And then, of course, the DEQ is done simultaneously, and they work with the BLM to negotiate bonding and things like that. Yeah.
Said that south part, that south slope was sage browse. So is that in core, or what the BLM would call primary habitat?
It's neither. It is general habitat. I was just talking with Emily, who's evaluating our sage grouse application right now, which we're expecting to be complete in another week or so. And so it's general habitat.
Awesome. Okay. Thank you.
Any more questions for Greg? All right. Well, thanks, Greg.
You're welcome.
Out of your